Any ill effects from the Van Allen radiation belts?
No, now I'm not sure we went far enough out to.
Hello, everyone. In this video, we will understand what the Van Allen belt is and why it makes traveling to the moon unfeasible, and how the astronauts themselves contradict themselves regarding this issue. Well, let's start at the beginning. What is the Van Allen belt? I will explain the scientific approach. The explanation will be a little long, but understanding is necessary. Discovered in 1958 by James Van Allen, professor and director of the Physics Institute at the University of Iowa, James also conducted investigations into nuclear physics, cosmic radiation, and atmospheric physics, also worked on the projects of the first artificial satellites in the United States, and participated in the planetary investigation linked to NASA's Apollo, Mariner, and Pioneer missions. The Van Allen belt is a region where several atmospheric phenomena occur due to the concentration of particles in the Earth's magnetic field, forming a belt around our planet. I don't like using the term planet, but let's keep the word as it has been taught to us in schools. Continuing the explanation. These belts are composed of two annular regions, known as the inner belt and the outer belt, which are coaxial with the geomagnetic axis. This means they are aligned in such a way that their center, or axis, coincides with the Earth's geomagnetic axis, forming a kind of protective shield around the Earth that follows the orientation of the Earth's magnetic field. The inner ring begins at an altitude of 1,000 kilometers and extends to a height of 3,000 kilometers in relation to the Earth's surface. The outer ring is formed at a distance of 2,000 kilometers to 3,000 kilometers from the center of the Earth, based on the average radius of the Earth being 6,371 kilometers. We can consider that the outer ring is at an altitude of 14,000 kilometers to 23,000 kilometers altitude. They are quite high indeed, but we have a problem here. All manned space missions from NASA or the Soviet Union were far below this region: Gemini, Mercury, Soyuz, Skylab, the Space Shuttle. They all traveled below this radioactive zone, with the exception of the Apollo missions. Since the height of the Moon and the Earth's surface is 38,400 kilometers, to reach the Moon, it would be necessary to pass through both rings of the Van Allen belt. Okay, but how difficult is it to overcome them? The Van Allen radiation belts, because they are loaded with high-energy protons in the inner ring and high-energy electrons in the outer ring, present significant risks to satellites, astronauts, and spacecraft that pass through these regions or operate within them for prolonged periods. For example, damage to satellites and space instruments. Intense radiation can damage the electronic components of satellites and spacecraft, affecting their functioning. This includes damage to circuits, degradation of materials, and failures in communication systems. Health risk to astronauts. For astronauts traveling through the Van Allen belts, there is an increased risk of exposure to radiation, which can cause adverse health effects such as damage to cellular tissue and an increased risk of cancer. Interference with instrumentation and communications. Radiation can interfere with scientific instruments and communication systems on board spacecraft, resulting in corrupted data or loss of communication. Okay, and how does NASA avoid this problem? We learned that they use shielding in spacecraft to protect against radiation and the development of radiation-resistant electronic equipment. In addition to that, spacesuits are also designed to minimize exposure to radiation and route care to reduce the time spent in space belts. Okay, but let's see other details about the Van Allen belt that opens up some extra questions. For example, information from NASA itself indicates that the flow of electrons with an energy of 3.6 MeV. What does this mean? MeV, or mega electron volt, unit of energy, used in atomic and nuclear physics, equivalent to 1 million electron volts. The temperature within the Van Allen belts is not measured in the same way as the temperature on Earth or in near-Earth space, due to the nature of the energetic particles that make up the belts. Instead of a temperature in the traditional sense, it is more accurate to talk about the energy of the particles. However, one can relate this energy to a particle temperature in terms of their kinetic energy. Like high-energy electrons and ions, they are in constant motion and interact with the Earth's magnetic field. In plasma physics, this energy is often expressed in terms of kiloelectron volts, keV, or mega electron volts, MeV. In other words, we should not simply convert these units to Celsius, but since it is possible to do such a conversion and the justification for using these units was not convincing to me, in addition to camouflaging extremely high numbers, I will convert. Using a unit converter, we arrive at the result that 1 electron volt is equal to 11,331 degrees Celsius. However, I looked for other converters to compare the result. I only found the option of converting electron volt to Kelvin, and then converting Kelvin to electron volt. Using this logic of reasoning, the result obtained for 1 electron volt will be equal to 11,604 Kelvin, knowing 1 Kelvin is equal to 273.15 negative degrees Celsius. In this way, considering 3.6 mega electron volts, or 3.6 million electron volts, we arrive at the following result for both conversion lines: 41 billion degrees Celsius. This result to me doesn't make any sense to survive during a space trip. Even considering 0.1% of this temperature, it would be surreal. But can you believe that something would be able to cross this part of radioactive energy with temperatures of this type just based on a special shield? Honestly, to me, not even this temperature sample makes sense. It is actually much higher than the temperature that we are told is the surface of the sun, which we are told is 15 million degrees Celsius. While science still teaches us that we have the plasmasphere, a giant cloud of charged particles that is approximately 1,000 kilometers above the Earth's surface, extending to the outermost belt, which would act as a shield. The particles on the outer edge of the plasmasphere cause the particles in the outer belt to disperse and begin to move quickly around our planet. This movement is capable of repelling the most energized electrons that try to move towards the Earth. If left unchecked, these electrons could be harmful. Observations showed that very energetic electrons always remained at a certain distance from the Earth. It was discovered that the inner edge of the outermost Van Allen belt functions as a boundary that these electrons cannot penetrate under normal conditions. The existence of the plasmasphere makes me believe how we cannot suffer the consequences of the high energies of the belt every day. But you can't make me understand how something could go beyond the plasmasphere and the two belts. Let's evaluate other details. For example, tungsten is the chemical element with the highest melting point among metals, being equal to 3,422 degrees Celsius. That is, there is no known material on the Earth's surface that will not melt at temperatures higher than this. You ask, what material does space shielding make? The materials used in Apollo's armor were aluminum, believe it or not, but it was aluminum. Its melting point is only 660 degrees Celsius. They also used plastic composite materials, such as polyethylene, to absorb neutrals. They say they are useful for protecting against low-energy charged particles, right? But what about when this protection passes through the high-energy section? Wouldn't it melt? In addition to using water as a shield against radiation, well, I try to believe it, but they don't help me. Really? Using water? Well, let's see what our dear astronauts have to say about their surreal experience crossing the Van Allen belt. Something like this is an experience that they couldn't let go unnoticed, right?
Any ill effects from the Van Allen radiation belts?
No, now I'm not sure we went far enough out to encounter the Van Allen radiation belt. Maybe we did. I don't know the distance to the Van Allen radiation belt, and if we did, it wasn't a problem.
The belts are 1,000 miles to 25,000 miles above the Earth.
We went right out through them.
No effects on your cells?
We didn't even know it. I don't think anybody, well, maybe somebody said you went through the radiation belt, but we didn't feel it inside, and we didn't get any, added radiation.
No strange occurrences?
Nothing like that.
I saw a CNN report about 3 years ago. The space shuttle went to about 365 miles, and that was the closest they got to the belts since the moon missions went through them. And they were about, 650 miles away from the belts. And they reported that it was more dangerous than previously believed, and that when they were 650 miles away, inside a shielding better than you guys used, they could see the radiation with their eyes closed going through their skulls and the retinas of their closed eyes.
Well, I don't know about the shuttle. The shuttle doesn't have the capability to go very far, 400 miles. I don't know exactly where the Van Allen. Quiet. Hey. Hey, quiet. The shuttle doesn't have the capability to fly very far away from Earth, maybe 300-400 miles. I don't know exactly how far out the radiation Van Allen belt is. It didn't seem to bother us very much.
Did you see shooting stars?
Did
you see the shooting stars?
Yeah, I'm getting to that.
Oh, okay.
But A lot of noise going on. So I don't know the results of some of the experiments they've conducted. The point is they can't get that far from here, and they're really in the protective confines of the Earth, outside the atmosphere certainly. Now on the way to the moon, we did conduct lots. We weren't passengers away to the moon.
We're passengers.
We conducted all kinds of experiments, and one of them was an experiment where we closed our eyes and then we put some light-sensitive pads on our eyes, and we could literally, yes, we could see traces of radiation or traces of something going through our eyes. We conducted this experiment both going to the moon and coming back from the moon several times. Now, what that all meant, I don't know, but it wasn't the kind of radiation that gave us a problem of any kind. But you could see it. You could close your eyes and you could see these things shoot by. We all saw it.
Not on our mission, by the way, they hadn't been discovered yet.
Don't you remember? They seemed quite contradictory to me, especially Alan Bean, the fourth man to set foot on the moon, was a crew member on Apollo 12. He didn't even know about the existence of the belt. Maybe he didn't actually make any space trips. Only 12 men in all of history had the experience of going to the moon. If we imagine that the world population is 8 billion people, we are saying that only 0.0000015% of the population had this privilege. They were hand-selected because they were the most capable and didn't have this information about what they would face on the way to the moon. Forgive me, but I can't believe it this way. The story is very poorly told. Well, I'm going to give my opinion. You don't have to agree with me, but it's open to questioning what you believe about this story. For me, it starts off wrong with this issue of absurd temperatures. How did you measure this? With which instrument? On the basis of mathematical predictions without real experiments? That is, based purely on faith? Because that's what it seems to me. Faith on the science. I need to believe in the numbers they give me. Believe that it is possible to overcome these limitations that they themselves present with absurd solutions where witnesses don't remember the event. In other words, I need to have faith in NASA to believe in them. I need to reserve my faith in believing only in the words of Jesus Christ and not financing this space theater. That's it for today. Subscribe to the channel to see more videos like this and much more.